Welcome to my first video in a series of educational material I'm planning to release. And the plan is to start from the basic topics in mathematics and work our way up to more complex areas. Today we're starting off with a very basic intro to algebra. So the first thing I thought we should discuss are the rules of algebra. So first rule, commutativity. So two numbers x and y can be added or multiplied in any order without affecting the results. So what does that actually mean? Well, if you do x plus a, x plus y, or you do y plus x, you end up with the same result. So as an example, if we say x equals 3, y equals 2, uh, then you've got x plus y is 3 plus 2 is 5, or you've got 2 plus 3, which is also equals 5. And the same for multiplication. So if you did x times y, that gives you the same result as if you did y times x. So 3 times 2 equals 6, or 2 times 3 equals 6. So the operations addition and multiplication are said to be commutative. Now, what about subtraction and division? Well, they are not commutative. So for example, if you did x minus y, or if you did y minus x, you would get different results. So if we take the same numbers as previously, if you do 3 minus 2, you get 1. If you do 2 minus 3, you get minus 1. They are not equal. Okay, it's very important. Same thing with division. X divided by y does not equal y divided by x. So again, x divided by y in this case is 3 over 2, and y divided by x equals 2 over 3, and they are not the same results. Next rule is associativity. So the way numbers x, y, z are associated under addition and multiplication does not affect the results. Again, what does that actually mean? Well, if we look at it this way, so if you did if you did y plus z and then you added x, you would get exactly the same result as if you did x plus y and then add z. It would always be x plus y plus z. So let's just look at an example again. So if we do x equals, let's say 5 now, y equals 4, z equals 3. So if you did y plus z, you'd get 7 plus 5 is 12, or if you did 5 plus 4 is 9 plus 3 equals 12. Doesn't matter. Same thing with multiplication. So if you did y times z and then times by the x, or you did the x times y and then times by z, you would get the same result. So let's just do the same example. So 4 times 3 is 12, times by 5 is 60, or if you did 5 times 4 is 20, times by the 3 is 60. The same. Again, subtraction and division are not associative. So let's have a look at this. We'll do it with the example. So if you did 5 minus 4, that's 1. Minus 3 is minus 2, so this one gives you minus 2. But if you did y minus z first, you're looking at 4 minus 3 is 1, and 5 minus 1 is 4. Not the same result. And division, same thing, we'll just do the example. 4 divided by 3, so this is 5 over 4 divided by 3, which equals 15 over 4. And on the right side, if you're looking at 5 over 4 all over 3, which equals 5 over 12. They are different results. Okay, very important. Final rule, distributivity, right? So multiplication is distributed over addition and subtraction from either left side or right side, right? So what does that mean? Well, if you did y plus x and then you multiplied, so y plus z and then you multiplied by x on the left side, you get x, y plus xz. And then if you did the same thing on the right side, so x plus y multiplied by z on the right, you'd get xz plus yz, right? Well, let's just do it, another calculation. So if we look at x equals 5, y equals 4, and we've got so z equals 3, we're looking at y plus z is 7 times by 5 equals 35, And then if we did on this side, if we did x times y, you're looking at 20, and then z times x is 15. That is the same. We'll just look on the right hand side of the right hand side now. So x times x plus y equals 9 times by z is 27. And then if you did x times z, which is 15, plus 4 times 3, which is 12, that is 27, right? Same thing for subtraction. I'm not going to do the calculations there, but the same thing, same rules hold for subtraction. The key is that is now negative. That negative becomes negative, right? Division, right? Division, however, is only distributed over addition and subtraction from the right side and not the left side. What does that mean? Well, if you did x plus y and then you divide it by z, that would be the same as if you did x divided by z plus y divided by z. So let's look at that example. So x plus y is 9. 9 divided by 3 equals 3. And then if you did a bit of work here, so if you did 5 over 3 plus 4 over 3 equals 9 over 3 equals 3, right? Now let's look at the same division function, but from the left-hand side. So it's just looking at the same thing. I'm just going to log this out. This is looking at the same thing from the fraction side of things, right? So we know this to be true. You can split this up quite easily, and you can combine it in the same way. But if we look at the equation on the other side, right? So if you had x divided by y plus z, that is not the same thing as x over y plus x over z, right? So this is not equal. Let's just do an example. So if we did 5 over 4 plus 3 is 7, and on the right hand side it's 5 over 4 plus 3 over 5 over 3. That's greater 1, so it's obviously not the same as that. And that will do. That will do for this video.